Today, I would like to talk about how to select your recording patch when you acquire a Seismic program. Now, first I'd like to start with costs. Well, that's pretty simple. The smaller your recording patch, the less equipment you need, less people you need in the field, the cheaper your seismic crew will be. Now, that becomes pointless to require a seismic program if you do not reach your business objectives of your 3D. So that's why when selecting a recording patch, I look at it from the business perspective and the business objectives. And I group that into two categories. One, traditional imaging. Traditional interpretation, what you would normally do with seismic data in the more historical sense. Second, a more advanced imaging, such as AVO inversion, fracture detection, and so on. So first, I would like to talk about more traditional imaging. And that all comes down to usable to offset depth ratio. Now, the easiest part of this is you could go look at a processing mute and get an idea of where the processor actually muted the data, where the limits were for what the usable points of the data were. Now, the thing is, processing mutes are subjective to the interpretation of the processor. So it is also really important to look at some real data yourself. The best component is looking at a common offset stack. When you look at a common offset stack, you can get a real feel for what your usable offsets are for the different target zones you may have for your objectives of your 3D. It allows you to see where the mute is. It allows you to see where your NMO stretches and relative to where your processing mute is, and gives you a good feel for where you need to be and what offsets you need to record. And if you were to compromise that, what would you be compromising? So that's a great first start, but you can't stop there, which many people can do. You also need to look at the refraction solution. Now, the refraction solution, really you need to understand that you gotta get a good V0, V1, and V2 solution. And if you miss that, it obviously can compromise your entire refraction solution and the quality of your seismic data. Now, if you have a shallow target, it is possible, and happens quite frequently, that your usable offset to depth ratio or usable offsets, when you look at it from an imaging perspective, will be smaller than the offsets required for your refraction solution. And that's why it's so important to do both. Now, I would like to go into the second category, looking at advanced interpretation, AVO inversion, fracture detection, and so on. Now, we got to look at things at a little different perspective here. We're now interested in critical angles. What are the critical angles of the different target zones? What are the incident angle ranges for the different target zones? Understanding when you say would hit 40 degrees or 50 degrees incident angles at your target zone, which is relative to determining your density term. Now, you got to throw in the caveat, of course, are you just recording P-wave data, or are you recording converted wave? Because that obviously impacts the incident angles needed for your seismic project. Now, you also need to take into account things like, are you going to do near offset stacks, far offset stacks? Are you really into fracture analysis? And that's obviously important to get a full range of offsets and azimuths consistently for your far offsets. Now, when you got this all figured out, now you can go into determining your inline offsets and your crossline offsets. Well, inline offsets are relative to the length of your receiver lines. Now, they're considered cheap. Pretty simply, they are considered cheap because typically the acquisition company will lay the entire line out. Equipment's on the ground. Honestly, in many cases, you might as well record it. In crossline direction, it is more relative to every time you add a line, you need a bigger crew, more people, and your costs can go up exponentially. So that is why it is so important that you minimize that to only reach the technical specs that you've previously designed and what we've talked about in the previous two categories. Well, that's all I have for now. Please leave questions, comments, and thank you for listening.